Howdy, folks. I think I've been outsmarted by an acquaintance of mine. He's been requesting that I do a full-blown analysis on something, following all the steps throughout the whole process. And being the lazy guy that I am, I never do it. I always find a clue or take some information and try to narrow it down a little bit so I don't kind of keep the testing a little bit simpler. But I think he's got me foiled. He actually sent me a couple of samples here with very little information, so I'm kind of stuck going from square one and working through it. They're already powdered up and ready to go. The first one, he says, is a simple water-soluble salt to take a look at, and he says just analyze what the cation is, so that should be pretty simple. But still, I have no clue to what it is other than that. And the second one, he said, was a mineral. The only information I have is that it has a specific gravity of 2.6, which is kind of right in the mid-range of all the silicates, so I don't know if that's a lot of information. But he did say the hardness was 2, so that's pretty soft. But still, not enough for me to narrow down any testing protocol, so I'll have to go through pretty much the whole procedure here. So anyways, I'm going to start with the simple one first, at least with what I think is simple, and that's the salt. He said it's water soluble, so I can go ahead and dissolve it in some water and start trying to precipitate out different cation groups to see what's in there. So this will be a lot of fun. What's nice about it is that my friend knows the real answer. So when I get done, I don't have to wonder if I got it right or not, because he'll tell me. The other thing is this sort of takes you back. I don't know if any of you have actually taken a general chemistry laboratory in college, but back in the olden days they used to cover some of the qualitative testing as part of the lab work. And at some point they gave you an unknown and you'd had to go through and test it and come up with what it was, and that was part of your grade. And I remember doing it, but I don't remember what my material was, nor do I remember if I even got it right. So this will be a lot of fun. Now, I have been thinking about this, and I have come up with a couple shortcuts, possible shortcuts. And I figure before I get started, I'll do a quick flame test and a quick borax bead. And what that'll tell me if it's one of those metals that show up on those tests, and not all of them do, but if it is, I'll have some idea what it is from the get-go. Regardless of what happens or what the results are of the flame test and the borax bead, I'm going to go ahead and do the full analysis anyways. So let's go ahead and get started. Looks like I have a nice clear bead, so I'm going to dip it into a little bit of the sample. Okay, the bead is quite orange-red when it's hot, and it's turning a deep red when it's almost black when it's cool. So that to me indicates that it's manganese. But we'll go ahead and do some of the other testing here and find out. Here's the flame test with just the bare wire with a little bit of acid on it. Not seeing much color there at all, really. Usually I get sodium in there. We're going to dip it back in acid and put it in our sample here. Get a little bit of sample on the wire. Now we'll try it again. Boy, if I did, I can't really pick it out. I'd call that no real color. So that would be consistent if it was manganese. Since this was described to me as a simple salt, I'm going to use this reference for the analysis. It's a semi-micro qualitative analysis book, and I'm using it because it's pretty much the only one I have, but it does seem to be like a pretty good reference. It's by C.H. Sorum as the author. If you look at the kind of first steps for dissolving a sample, it says to look for the color of the solid, and it gives a list of different common colors. I don't know if you can read any of this, but chromate is yellow, dichromate is orange-red, manganate is violet-purple, Nickel 2 is green, iron 3 is reddish brown to yellow, iron 2 is grayish green, chrome 3 is blue, gray to black, yada yada. Manganese is pink to tan. And if you look at our sample here, here's the two of them. The one on the left, which is the salt I'm looking at, definitely has a pink color, so I don't know if you can pick that up on the camera. So that kind of also supports the possibility that it might be a manganese salt. The procedure actually calls for dissolving the volume of equal to 2 drops, and I don't know where in the world they got that. Trying to convert that to a solid is a little bit difficult because I don't have anything that measures in drops for a solid, like a spoon. There's generally 20 drops in a milliliter, so 2 drops out of 20 is about 1/10 of a milliliter, and if it was water, that would weigh 1/10 of a gram. And I'm assuming the solid's going to be about twice as dense, so that's going to be about 2/10 of a gram. And they say to dissolve 2 drops volume into 5 mils of water. So I'm going to use the 2/10 of a gram, which is consistent with the other references that I have too that use about 1/10 of a gram to 2/10 of a gram, or somewhere in that neighborhood. So that's 2/10 of a gram of the solid and 5 mils of water. And we'll give that a shake. And supposedly it's water soluble. I was told that. So we'll see if that's true and how easily it dissolves. So this material dissolved fairly rapidly and completely. The first thing we're going to do is test for the silver group. I'm going to assume that there's nothing weird as far as rare earth elements or anything like that. So we're going to go right to testing for the silver group, which means we add a chloride, and if there's a silver, lead, or mercury chloride that is insoluble, you'll see it as a precipitate. So, according to the procedure, it is really semi-micro. You only use about 5 drops of the solution. So I'll steal that. Alright, that's 5 drops. Holy cow. And you're supposed to add 2 drops of 6 molar hydrochloric acid. I'm too lazy to dilute it. Concentrated is about 12 molar, so I'll just add 1 drop. And we have absolutely no precipitate. So adding the chloride would precipitate out the silver group with all the insoluble chlorides of silver, mercury, and lead. But there's no precipitate, so we can rule out silver, mercury, and lead. Now we're ready to try to precipitate out the copper and arsenic groups, as they are called in this reference. That includes any remaining mercury and lead that wasn't precipitated in the last step. It also includes things like bismuth, copper, cadmium, arsenic, antimony, and tin. There's also other stuff that will precipitate out on this step too, like some of the platinum group metals and a whole bunch of other things too, but they're not very common. But these are the common cations. But like this whole procedure, there's each step entails a whole bunch of sub-steps. It's basically bubbling hydrogen sulfide through and precipitating all these things out as sulfides, but there's a bunch of steps. So let's go ahead and do them real quick here. We have 4 or 5 drops of our unknown solution to it says a casserole. I'm going to use a beaker. We add 2 drops of 3% hydrogen peroxide and a couple of drops of 2 molar hydrochloric acid. We boil the volume down to 1 to 2 drops. Now we add 6 drops of 6 molar hydrochloric acid, and we dry that down, heat that down to a gummy mass. Now we add 4 drops of 2 molar acid and transfer that to a test tube. Once it's transferred to the tube, we're supposed to heat till effervescence. Now we're supposed to treat it with hydrogen sulfide gas. This is a carbon, paraffin, sulfur hydrogen sulfide generator. It produces hydrogen sulfide gas when it heats up. Now we dilute with 10 drops of hot water and treat this for another 20 or 30 seconds with hydrogen sulfide gas. Now we add 1 drop of ammonium acetate, and we treat it yet again with hydrogen sulfide for another 20 or 30 seconds. Now we add 25 drops of cold water and treat it one last time for another 20 or 30 seconds with hydrogen sulfide. Well, we have no precipitate, and that was a lot of screwing around just to find out that the copper and arsenate groups are absent. I'm sure there's a description on, or some explanation on why you have to follow all those bazillion steps rather than just adding hydrogen sulfide gas to it. I guess it has to do with the solubility at the different stages of different materials, but oh boy, that was a lot of work. But anyways, no copper, no arsenate, no tin, no antimony, no cadmium, and some other materials either. So we'll continue with the next step. Now we're going to try to precipitate out the aluminum nickel group. At least that's what this reference calls it. And that includes iron, cobalt, nickel, manganese, aluminum, chrome, and zinc. Basically we use ammonium sulfide, but there's a whole bunch of sub-steps involved here. So let's go ahead and get those done quickly. I'm starting with fresh solution, otherwise we'd have to get all the old hydrogen sulfide out from the last step. So it says 3 drops, and I'm going to double it up to 6. That'll make things a little easier to see. We're supposed to add 4 drops of 2 molar ammonium chloride. Now we need to add ammonium hydroxide until just basic. And then an extra drop. Now we add 40 drops of hot water. Actually, that's 2 mils. Now we add ammonium sulfide. Now we heat in a hot water bath. And after centrifuging, eureka, we have a precipitate. Now that looks pretty brown. Supposedly if it's a manganese material, it should be more peachy colored, and iron is browns. Now we wash the precipitate in hot ammonium acetate solution. Alright, we're getting somewhere now. We have a precipitate that is supposedly the aluminum nickel group. Now we're supposed to separate out the aluminum subgroup, which contains the aluminum, chrome, and zinc, from the nickel subgroup, which contains nickel, iron, manganese, and cobalt. Once again, there's a whole bunch of steps. Basically, you acidify it and then take the pH up, making it basic once again, and putting in an oxidizer. But we'll go through the bunch of steps, and for some reason they have you transferring it from a test tube to a casserole, to a test tube to a casserole, to a test tube, yada yada yada, for no apparent reason, because you're not really boiling anything off. So I'm going to just do it in a test tube. So let's get started. We add 10 drops of concentrated hydrochloric acid and boil gently for a half a minute. Everything dissolved, and I added 10 drops of cold water. Now we're supposed to centrifuge to get out any sulfur, but it's totally clear, so we're going to skip that. Now we make it strongly alkaline with 8 molar sodium hydroxide. No, still acidic. Nope, still acidic. Alright, now we're basic. Now we add hydrogen peroxide. Mix for 1 minute. I did put it in a larger tube, and we're supposed to boil for 2 minutes. Alright, we have a nice precipitate that is formed, so we definitely have something from the nickel group. So there's our precipitate. We're down to 4 cations. Nickel, iron, manganese, or cobalt. Notice the black color. I know the manganese oxide is a black color. So we'll see what we get. Now we wash the precipitate 3 times with hot water. And now to our washed precipitate, we add 2 mils of 2 molar sulfuric acid. We boil that for 1 minute. Now we add a couple drops of hydrogen peroxide and boil until dissolved for another minute. Now for the nickel test, we take a little bit of the solution and we need to make it basic again. Alright, once we have it basic, we're supposed to centrifuge out any iron and manganese there. Now that we've centrifuged this, we can go ahead and do the nickel test. We add dimethyl gloxine to it, Just a drop. Alright, we're supposed to let that stand, and we should get a strawberry color to it, but we're not getting anything at all, so there's no nickel. Now to some of our solution, we're going to add a drop of potassium thiocyanide. And if there's iron there, it'll turn blood red. Alright, maybe a little bit of a pink color, but definitely not blood red. So I would have to say that the main cation there is not iron. Now the manganese confirmation test in this book uses sodium bismuthate, which I don't have, and it's difficult for me to get or make. So the other confirmation test that is quite common, in addition to the borax bead, which we already did, is an oxidation fusion with 4 parts soda, 1 part potassium nitrate, and the sample. So we're going to get that ground up. And you can really see the blue color on some of those beads that I just started to do the fusion on. So definitely manganese. Well, there we have it. It was a manganese salt, or at least that's what I came up with. I'll have to check with my friend to see if I got it right. So I guess my shortcut there in the beginning was accurate with the borax bead, and that doesn't always work, but it was confirmed going through the steps of the wet chemistry. So anyways, I do have another sample to look at that he gave me, and it's a mineral sample, and I have a feeling this is going to be a lot more difficult. But I'll probably do a borax bead and a flame test from the get-go too, to see if that gives us any information or not. It might not. So thanks for watching the video, and thanks again to my friend for sending the sample. It was a lot of fun trying to find out what it was. Have a great day, and happy mineral identification.